All right, so look at this little table right here. It's kind of telling you the difference between mixtures and compounds. So the composition of a mixture, basically what it's made up of. So the mixture is made up of different things, right? Variable composition. You can vary the amount of each substance in a mixture. So you can have a ton of one type of thing and just a little bit of another. It doesn't matter. But in a compound, you have to have definite composition. It has to be the same every time. You can't vary the amount of each element in a compound. So again, for every two hydrogens, you have to have one oxygen, H2O, right? For in table salt, for every Na, you have to have a Cl, one Na, one Cl, 1 to 1. For CO2, carbon dioxide, the gas that you exhale, C, you have to have one, and O2, you have to have two oxygens every time. The way they're joined is in a mixture. They're not chemically joined together. You can think of this as like a salad, right? A salad is a mixture. It's got lettuce and cucumber, tomatoes, whatever else you put in it. They're not chemically joined together, right? The lettuce doesn't chemically fuse to the cucumber. They're just kind of laying on top of each other, right? But in a compound, the different elements are chemically joined together. So you cannot separate these things just by pulling them apart. Some kind of chemical reaction has to happen to separate them the way it had to happen for them to come together. And when it comes to properties of mixtures, each substance in the mixture keeps its own property, right? Again, just think of a salad. When you put a cucumber on top of lettuce, it doesn't mean that like all of a sudden the cucumber starts getting the properties of the lettuce, right? It doesn't start turning into a leaf. No, they keep their own properties. In a compound, the compound has a properties different from the elements it contains. So this is where I was saying that Na is like this explosive solid, and Cl, chlorine, is this poison gas. But when you bring them together, they actually turn into something completely different, table salt, right? And then the separation. For a mixture, each substance is easily separated from the mixture. So again, the salad example, you just take off the cucumbers, you just pull off the tomatoes, you just separate them. In a compound, you can't separate them just by pulling them apart. It has to go through some kind of reaction for them to separate. So what I was saying earlier, H2O, through the process of photosynthesis that plants do, that actually can separate the H and the O's, and it can release oxygen gas, right? So, and it uses the hydrogens for something else, but it releases the oxygen into the atmosphere, and that's why we get oxygen from plants. And then examples of mixtures are air, seawater, most rocks, right? Air, I know it sounds kind of weird, but in the air we have nitrogen, we have oxygen, we have carbon dioxide. There's all these things. I think there's neon in the air around us, right? A mix of everything. Seawater, same thing. It's made of salt and water and like old seashells and probably oil and sewage at this point. And then CO2, when you're talking about examples of that, water, which is H2O, carbon dioxide, CO2, magnesium oxide, sodium chloride, which is table salt. And we're going to see sodium chloride, NaCl, a lot this term. So these are just the differences between mixtures and compounds.